if I want to expand log expressions, let's say, for example, I'm going to expand natural log of 4m cubed over n squared. Anything that is on the top in the numerator has to have a positive sign in front of it because it's multiplication. Anything in the denominator has to have a subtraction sign. So there are 3 different items that I have to expand. The 4 has to have its separate one. So I have natural log of 4, natural log of m squared, natural log of n squared. So I'm going to keep them all separated, and those things that are in the numerator should have a plus between them or a plus sign in front of them, and anything in the denominator should have a minus sign. Next thing I'm going to do is move my exponents to the front. So this is natural log of 4 plus 2 natural log of m minus 2 natural log of n. And that is my expansion. Okay. Let's try another one. So I have log of 2x minus 3 over 3 times the 4th root of x. Okay, again, I have one item here. You do not separate these, a 3 and a 4th root of x. So that's log 2x minus 3, log 3, log 4th root of x. They get a minus sign for the 3 and the 4th root of x because they're in the denominator. The 4th root of x you can rewrite as x to the 1/4, and then you're going to move your x to the 1/4 to the front. So I get log 2x minus 3 minus log 3 minus 1/4 log x as my final answer. Natural log ex squared over the square root of 4x plus 1. So again, I have an e, I have an x squared, I have a square root of 4x plus 1. Here's the original problem. This gives me natural log of e, natural log of x squared, natural log of, and I'll do all this at one time, 4x plus 1 to the 1/2, because you're going to change square root to the 1/2 power. Then I need addition and subtraction. Natural log of e is 1. I can move, if you can simplify this, you need to. My exponent 2 moves to the front, and the 1/2 moves to the front. Alright, next we are condensing log expressions. So for our first example, we have 4, oops, let me make this thicker. 4 log x, oops, log base 3x minus 1/3 log x plus 6. So to do that, we're going to undo, or we're going to redo what was undone. So we're moving the exponent of 4 up, the 1/3 up, and remember 1/3 means cube root. So this is going to give me log base 3 of x to the 4th minus log, oops, I forgot a 3, log base 3 of x plus 6 to the 1/3. And I'm going to change that back to cube root in a minute. And since I have subtraction, we're going to condense this into division. X to the 4th over cube root x plus 6. If there is an addition sign in front of it, then it's going to go in the numerator. If there's a subtraction sign, it's going to go in the denominator. Okay, another example. So 5 natural log x plus 1 So then for this problem, again, I'm going to move my 5 up, move my 6 up, move my 2 up. That's going to give me 1 natural log. My x to the 5th, since this is, oops, since this has a plus in front of it, it's going to go in the numerator. This has a plus in front of it, it's going to go in the numerator. The minus 2 natural log goes in the denominator. It's going to give me x plus 1 to the 5th natural log x to the 6th, and then 3 squared goes in the denominator, which is 9. 5th. Oops. Hold on. We need to erase. Natural log shouldn't be there. X to the 6th over 9. And that is my condensing. So using the change of base, if I have, say for example, log base 3 of 5, obviously you're not going to be able to do 3 to the sum power gives you 5. You're not going to be able to figure that out. So in the calculator, there are shortcuts in the calculator, and I'll show them to you in class. Or you do change of base, which is actually going to be better for you to know based solely on the fact that I know what's coming when you have to solve. I still want to make sure you know change of base. This is going to be log 5 divided by log 3, and that gives me 1.47. The other thing you can do too when you do logs, instead of doing log 5 or log 3, you can also do your common logarithm, log 5, natural log of 5 over natural log of 3, and it will actually give you the same thing. Oops, not 7, or not 3. That should be a 7. And that's the end of 3.3.